Hello, everyone. So we have another geometry problem. This was a MATHCOUNTS chapter competition on a team run. So this was a number 10, so which is most challenging question to be. So let's see if this is really the case. So we have two congruent circles P and Q, so which is right here and there. Internal tangent, meaning then they are touching each other at single point, which is right there. And to the circle O. So meaning that this point O, the intersection of P and Q, is the center of the larger circle as well. And external tangent to each other at point O, right? So which is given. The circle S, which is this circle, internal tangent to circle O, which is the largest circle because it is touching inside, and external tangent to both circles. So this is the tangency point. This is another tangency point. And what is the diameter of the circle S? So we are looking for the diameter of this. Let's highlight this part because we are not looking for the radius. So sometimes it's going to be tricky. So not to answer what we are looking for. So since we are told PQ is 24, and now we know that P and Q are identical. So which is why this has to be 12 and this has to be 12 as well. So whenever we deal with some circles, I highly recommend to take the center point and connect with the intersection, which is right here. But if you were to do this on the same side from the S to this intersection, this is going to be a straight line. Because the reason why it's going to be, if you were to draw this tangent line from here, so this radius will be perpendicular to this radius will be perpendicular to that tangent line. So which is 90 plus 90 will make 180. So this has to be a straight line. And the same reasoning, we are going to get the another perpendicular, like straight line segment from S to Q. But the question was asking us to find the radius of the S. So let's go ahead and write maybe that as well. So this is R, and this is R, and this is 12, and this is 12 as well, because this is radius, that's also. But you know, we do have a nice triangle right here, which is isosceles triangle. So if you were to drop the altitude, that has to right in the middle, which is passing through the center of the largest circle. But I don't really, like if I were to drop this, let me try that. Like I can see that this is gonna give us a right triangle, but I don't know this segment. But here's the question that I have. How do I get this red segment? Like, do I have anything else? Like if I extend this maybe red segment all the way to this intersection, I mean this point of intersection of this tangency point, this is the red one is the radius of the largest circle. And I do know this is my center. So if this is 12, so if you were to extend this, this is also 12, right? So all the way here to here is also 12. So meaning that the radius of the largest circle, which is O, is 24. So this whole thing is going to be 24. So if this is R, this piece, that means this part right here is 24 minus R. So let's go ahead and draw that. And this is really important skills when you are dealing with the segments in circles. Go ahead and find some triangles or some figures that you can handle easily by connecting some of the intersection. So that is what we did so far. So that is 12. And the hypotenuse is R plus 12. So that should be R plus 12. And then this is 24 minus R. So since we have a Pythagorean, like right triangle, we have all three sides. We can use the Pythagorean. So you can say 24 minus R squared plus R plus 12. I mean, plus 12 squared equals R plus 12 squared. And you may go ahead and expand the parentheses and find the R from there. But I'm gonna pause a second and see if I can get those values immediately. Sometimes it will be the case, so without really dealing with this equation. So I like to remember my triples, like 3, 4, 5 was one of my triples. And this is 12, so if I multiply like these by like some numbers to get this 12 to see if this is actually a triple. So let's try and see. If I multiply this by 4, so I get 12, multiplied by 4, so you get 16, multiplied by 4, you get 20. So if this is 12, that means this has to be 20, which means R has to be 8. 24 minus 8 is actually 16, so which looks like that is working. So the R is 8. Okay, so again, it's sometimes 3, 4, 5, sometimes the other tuples that we have might be useful. In this case, it was actually 3, 4, 5, just 4 times as like scale version of 3, 4, 5. And without really solving this equation, we got the R. But the question was asked in diameter, which is twice as much, and that is 16. So I hope that makes sense. This was a number 10, so I guess it is not too challenging. I'll see you in the next video.